Hey kids, today we're going to look at the derivative of the natural log function, and he's a little bit of an interesting one because it helps us out a lot later when we're doing some integration. And the rules for this guy are just a little bit unique because when we take derivative of a natural log, there's no natural log running around. So let's just go ahead and have a real quick refresher of what that might look like. If we look at the natural log, we're talking about the derivative d dx of the natural log of u. And that's just simply is going to be 1 over u times du dx. So when I take this derivative over here, there's a couple things that I'm going to do. One, I'm going to recognize with my rules of logarithms that anything in an exponent can be written in front of the log. So I'm actually going to work with the problem y equals 2 natural log of 2x. Okay. I think it makes it easier in the long run. Just me. You definitely don't have to do it if you don't want to. And in fact, if you don't want to do that, this whole piece right here, well, let me undo that. This whole piece right here is going to become your u. But that's not how I'm going to do it. So if you want to work it out separately, we should get to the same answer regardless, okay? What I'm going to do is I'm going to let u equal 2x. So du dx is going to be 2. And when I set my logarithm up, I'm going to have y equals 2 times the natural log of u. So now I take my derivative. Y prime is equal to 2 times 1 over u du dx. So now substitute in all the goodies, and that's going to give me 2 times 1 over u, and my u in this case was 1 over 2x, times the derivative of that, which is 2 over 1. So finish that guy out with your last step. The 2's can divide out, and I'm left with 2 over x, and that's your derivative. How easy is that, huh? Easy peasy lemon squeezy. Now if you work it out the other way, you should get the exact same thing. And you know what? Why not? Why not? I'm going to go ahead and work it out the other way too. So du dx, let's just go for broke. So if you didn't like how I did it the first time, here's the second time. Du dx is equal to 4x. So now when I work this out, I'm going to have y equals the natural log of u. So y prime equals 1 over u times du dx. And when I substitute in now, my 1 over u becomes 1 over 2x squared. My du dx becomes 4x over 1. And oh my gosh, look what's going to happen. One of those x's is going to go away. Let me get a change in color here. One of those x's goes away. And the 2 here goes away into that 2, and so I'm left with a final answer of 2 over x. And lo and behold, it comes out to be the exact same thing. Wow, who would have thunk it? That's why calculus is so darn cool.